Welcome to my algebra class. We're on chapter 5, section 11, and we're going to be factoring a number of different kinds of polynomials with different methods of factoring. And you have to factor completely, so keep these steps handy as you do your problems. The first step is always to factor out your greatest common factor. If you have a binomial, look for the difference of two squares. If you have a trinomial left, see if it's a perfect square trinomial. That's where the ends are perfect square and the middle's twice the product. If it is not, see if you can do product sum, where the first term, the x squared term, has a 1 in front. If not, then you need to split the middle. And if you have a polynomial of 4 or more terms, look for a way to group the terms in pairs or in a group of 3 that will give you a perfect square trinomial. When you're done, be sure all your factors are prime and check using FOIL. I have already taped this once before and something went wrong, so the problems are worked out and I'll try to go through them slow enough so that you can get through them. Problem number 2 through 6 are to go back to the oral exercises and do them. We have the problem 18x minus 8x cubed. Pull out your greatest common factor, which is 2x, and that leaves you 9 minus 4x squared, which is the difference of two perfect squares. So bring down the 2x, square root of 9 is 3, and the square root of 4x is 2x. So one of them has to be minus 2x and the other plus 2x. Problem number 4, you have 6ab plus 9a squared b minus 15a cubed b. Again, pull out your greatest common factor, which is a 3, an a, and a b. That leaves you 2 to get back to the 6ab plus 3a minus 5a squared. This is a trinomial. It's not a perfect square trinomial. The ends are not perfect squares. So we're going to use product sum, split the middle, since the number in front of a squared is a negative 5, not 1. So our product is negative 10. The sum is 3. And the two numbers that work are 5 and negative 2. And the 5 has to be positive for the sum to be positive 3. So we're going to split the middle. The 3a becomes 5a minus 2a. So bring down the 2 and the negative 5a squared. Then by grouping, you can pull out a 1, and that leaves you 2 plus 5a. Check the signs, positive, positive, negative, negative. Take out a negative a, and that leaves you 2 plus 5a. So there are three factors, 3ab times the quantity 2 plus 5a times 1 minus a. Problem number 6, we have 12x squared y minus 36xy squared plus 27y cubed. Again, pull out your greatest common factor, which is a 3, for the three numbers, and they all have a y. To get back to the first term, you need to multiply by 4x squared. To get back to this term, multiply by a negative 12xy. And the last term, a positive 9y squared. We have a trinomial, and if we look at the ends, they are perfect squares, so we're going to try a perfect square trinomial. The square root of 4x squared is 2x, so that goes here and here. The square root of 9y squared is 3y, that goes here and here. And if we multiply, we get negative 6xy, and that is twice that, so they're both minus. And our answer is the 3y times the quantity 2x minus 3y squared. Problem number 8, we have 6c squared plus 18cd plus 12d squared. Again, pull out your greatest common factor, which is 6, and it leaves us c squared plus 3cd plus 2d squared. Looking at the ends, those are not perfect squares, and the c squared has a 1 in front, so we just have to do a simple product sum. The product is 2, and the sum is 3. And the two numbers that work are 1 and 2. So we bring down the 6, take the square root of c squared, which is c, put that in the front. The square root of d squared, which is d, put that at the end. One of them has to be plus 1d and the other plus 2d. Problem number 10, we have 3xy squared minus 27x cubed. Pull out your greatest common factor, 3, and both of them have an x, 1x. To get back to the 3xy squared, we have to multiply by y squared. And to get back to the negative 27x cubed, we have to multiply by negative 9x squared. That's a binomial, and it is the difference of two perfect squares. So the square root of y squared is y, put that front. And the square root of 9x squared is 3x, and that goes at the end. One of them has to be positive and the other negative. And then we bring down our 3x. Problem number 12. We have negative n to the fourth minus 3n squared minus 2n cubed. Notice that the powers are not in order, so we're going to turn it around and put it in decreasing order. Negative n to the fourth minus 2n cubed minus 3n squared. We'd like to keep the quadratic term positive, so we're going to pull out a negative sign as well as the greatest common factor, n squared. So that leaves us n squared to get back to n to the fourth, negative n to the fourth, plus 2n plus 3. And this is a trinomial, and we just need to do product sum. Product is 3, sum is 2. And the only factors of 3 are 1 and 3, and that doesn't work. So our answer is the negative n squared and the trinomial. Problem number 14, we have negative m squared plus mn plus 2m minus 2n. This is grouping because we have 4 terms. So from the first pair, we can take out an m, and that leaves us negative m plus n. Checking the sides, negative, positive, positive, negative. Take out a negative 2, and that leaves us negative m plus n. So our factors are negative m plus n and m minus 2. We have 80 minus 120p plus 45p squared. Greatest common factor is 5, and that leaves us 16 minus 24p plus 9p squared. That is a trinomial. The ends are perfect squares. So I could take the square root of 16, put that down 4, and the square root of 9p squared is 3p. And check the middle. 4 times negative 3p is negative 12p. Double that up, it's negative 24p. So it works. So our answer is 5, bring it down, times the quantity 4 minus 3p squared. Problem 18. It's a binomial. Take out your greatest common factor, which is a 2, a p, and a q. To get back to the first term, you need to multiply by 4p squared. And the second term, a negative 9q squared. That's a binomial. It is the difference of two squares, so bring down the 2pq. The square root of 4p squared is 2p. The square root of 9q squared is 3q. One of them is minus, one plus. Number 20. We have 180x squared y minus 108xy squared minus 75x cubed. You can pull out a 3x, and that leaves you 60xy minus 36y squared minus 25x squared. We need to get this in decreasing order, so I'm going to put the negative 25x squared first, plus the 60xy to 1, and then negative 36y squared. I want to keep the quadratic term positive, so I'm going to pull out a negative 1 from everything. That makes that negative 3x. Now I have positive 25x squared minus 60xy plus 36y squared. That is a trinomial. The ends are now perfect squares, so I'm going to try to see if it's a perfect square trinomial. The square root of 25x squared is 5x. The square root of 36y squared is 6y. And if I times them together, I get negative 30xy, and the middle is twice that. So they're both minuses. And my answer is a negative 3x times the quantity 5x minus 6y squared. 22 is a little different. Use it to do 21. You have n times the quantity n squared minus 1 plus n times the quantity n minus 1. Realize that n squared minus 1 is the difference of two perfect squares, and it factors to n minus 1 and n plus 1. Now pull out your greatest common factor. Both have an n, so you have to pull that out. They both have an n minus 1. Pull that out. To get back to the first term, you need the n plus 1. To get back to the second term, you have to have something, so you put a plus 1 down. And then the answer is going to be n, the n minus 1, and then you can simplify that, and that's n plus 2. In the last problem, you have 81a plus 18a cubed plus a to the 5th. I'm going to turn it around, put it in decreasing order. Pull out the a, so now I have a to the 4th plus 18a squared plus 81. The trinomial is a perfect square trinomial, it seems to be, so I'm going to take the square root of a to the 4th, which is a to the 2nd, the square root of 81, which is 9. Check the middle, 9a squared, 18a squared is twice that, so I'll put the plus sign for both of them, and I have a times the quantity a plus 9 squared.